Hello, welcome back. The title of this lesson is called Order of Operations. This is part 1. And in these problems, we will have exponents and parentheses in addition to adding and subtracting and multiplying and dividing in these order of operations problems. Let me write the rules down on the board and explain to you why we have them. Essentially, we have to have a set of rules to tell us the correct order in which to do the calculations when we do long form calculations here. Let me show you the easiest way that I have found to remember these things. There's 4 short rules, all right? The first thing you need to remember is you always do parentheses first. So this means do parentheses first. If you ever see parentheses in a calculation or an expression, always do what's inside of there first, always, no matter what. Number 2, look for any exponents and do those next. Exponents, all right? So first priority is always do parentheses first. Next priority, always do any exponents that you see in the problem. Now, the next couple of rules give students some problems sometimes. Next, you want to do any multiplication and division. But notice that multiplication and division are not at different priorities. They're at the same priority. They're at priority 3. So if you ever see multiplication and division running around your problem, and that's all you have left to do is multiplying and dividing, multiplication does not come before division, because they're at the same level. What you do is you do it like reading a book. You do all the multiplying and dividing left to right, just like reading a book. All right, and then finally, after you've done all this stuff, you do the addition and the subtraction, but same thing. Addition is not more important than subtraction. These are at the same priority level, so if you ever see a bunch of adding and subtracting, just do it left to right, just like reading a book. All right, now some people use the following to help them remember this stuff. They use Pemdas, right? And I don't have a huge problem with it, but Pemdas actually can get you into problems sometimes, right? The P stands for do the parentheses first. The E means do the exponents next. Multiplication and division come next. Addition and subtraction come last. But the problem is it kind of tells you that multiplying comes before division, and it kind of tells you that addition comes before subtraction, but those things are not true. Notice the way I've written it, that multiplying and dividing are at the same priority level, and when you see both of them, you do them left to right. And then addition and subtraction is the same kind of thing. Let me give you a concrete example to show you what I'm talking about here. Let's say you have the problem 8 divided by 2 times 4. So the first thing you do is you say, well, do I have any parentheses? Nope, don't have any parentheses, so I'm done with that. Do I have any exponents? Nope, don't have any exponents, I'm done with that. So now I get to priority 3. I have multiplying and dividing, which is the only thing that's listed here. Now, if you follow Pemdas, you'll say, well, I don't have parentheses, I don't have exponents, multiplication comes next. Okay, multiplying comes next. So I have to do the multiplying next. 2 times 4 is 8, and then I do the division later, right? 8 divided by 8 is 1. But that's wrong. And that's exactly what Pemdas tells you to do. If you follow it exactly, literally, it's telling you to multiply before divide always, and that is not true. I'm going to say it again. That is not true. I'll say it again. That is not true. That's why I don't like Pemdas. You can use it if you want, but I actually like my way better. My way is saying, all right, look for parentheses, don't have any. Look for exponents, don't have any. Look for multiplying and dividing. Yes, I have that, but they're at the same priority level, so I do them left to right like reading a book. So 8 divided by 2 comes first. 8 divided by 2 is 4. Later, I have to multiply by this 4 because I'm doing it like reading a book, and that is 4 times 4 is 16. This is the correct answer. If you dump this into a computer or a calculator, the answer will be 16. If you follow Pemdas, you'll do multiplication first. 2 times 4 is 8, and then 8 divided by 8 is 1. That's just wrong. It's just not correct. So you can use it if it helps you remember this, but to be honest with you, I think we're going to remember it just fine without dealing with that. Let's take a look at problem 2. 3 plus 6 minus 2 squared. So the order of operations tells us what order do we do this? Do we do the addition first, the subtraction first? After all, it says addition and subtraction here on the same priority level. Which one do I do first? And then I have this exponent here. So you have to run through it every time. Do I have any parentheses? No, I don't. All right. Do I have any exponents? So that is the next thing I always do. And I'm going to have to rewrite this problem. 3 plus 6 minus, but now the exponent 2 to the power of 2. What does that mean? Anyway, we just learned what exponents mean. So go off to the side if you have to. 2 to the power of 2 is 2 times 2, right? because the power is 2, and 2 times 2 is 4. So we can replace this 2 to the power of 2 with the number 4. These two things are the same. And now I have addition and subtraction. And I don't use PEMDAS, I just look through my listing here. I've done the exponents. I don't have any multiplying or dividing, but I do adding and subtracting. I do it left to right like reading a book because these are at the same priority level. So what do? Left to right, 3 plus 6 is 9. Still have to subtract this 4, and 9 minus 4 is 5. The answer to this problem is 5. If you do these calculations in a different order, then you're not going to get the correct answer. So always parentheses first, then exponents, then multiply, divide, like reading a book left to right, then addition and subtraction, again, like reading a book left to right. Let's take a look at something a little more complicated. Let's say I have 5 to the power of 2 plus 7 times 2 minus 1. And don't forget that when I put a dot here, like I've done here, a dot here, that means multiplication. We want to get away from using an x from multiplication. Because an x, it gets confusing because we're going to be using x really very, very soon when we learn about variables. We'll be using x all the time, so we don't want to use x for multiplying. So you need to get used to seeing a dot meaning to multiply. All right, what is the first thing we check for? First thing is, do we have any parentheses? After that, we check for exponents. We don't have any parentheses here at all, so we're done with that. But we do have the exponent, 5 to the power of 2. And you can go off to the side here and remind yourself that 5 squared is just 5 times 5. 5 times 5 is 25. So this 5 squared becomes now a 25. Then I have plus 7 times 2 minus 1. Now a lot of students have no idea what to do next. Do I add next? Do I do the 25 plus the 7? Or do I do the subtraction? Or do I do something else? Well, you go in order. Parentheses, I don't have any. Exponents, I've already done it. Next, any multiplications and divisions must happen next. I only have one multiplication, so even though I have this other stuff here, I actually have to do this next. 7 times 2 is what? 14. And everything else about the problem just gets rewritten. This is the next thing I do, 7 times 2 being 14. Now I have a situation where I have addition and subtraction. I don't have any more multiplication or division. I have to now add or subtract, and I do it left to right. I don't try to pick which one to do, I do it left to right. 25 plus 14, maybe I'm not sure about that. So let's add these. I have a 9 here and a 3 here. So this becomes a 39. And then I have, whoops, not a plus sign. I have a minus sign 1. So I've done this and I have a minus 1, and then it's going to be 38, of course, because I only have one last thing there. And so the answer is 38. I cannot tell you how many people, including me when I first learned this, have a problem with order of operations. The problem is because people don't really learn and don't try to remember it. They try to find shortcuts and all that. Really, all you have to do is say, do I have any parentheses? Okay, do that first. Do I have any exponents? Do that next. Okay, any multiplying and dividing? Do that next. Okay, any addition and subtraction? Do that last. Take a look at the next problem. What about 3 plus 7 squared, close parentheses, divided by 4? First thing always, do I have any parentheses? Yes, I do. So I must do what is inside of here. But notice, what do I have in here? I have addition, but I also have an exponent. Now, inside the parentheses, you still have to follow the order of operations. So between adding and exponents, what do I have to do first? Exponents always comes before adding or subtracting. So I have to do inside the parentheses first, but even inside of there, 7 to the power of 2. Now, remind yourself, what is that? 7 times 7, right? Which is what? 49. So what we're basically saying is this 7 squared can be replaced with 49, and the 3 is going to be added later, and then I'm going to have to divide by 4 way later. I'm still working inside the parentheses. I did that first. Now, inside the parentheses, I still have to do this before I do anything else. What's 49 plus 3? 52. And once I calculate everything inside of the parentheses, I drop the parentheses. And now I have 52 divided by 4. 52 divided by 4. Now, that may not ring a bell, but you can, of course, go over here and do the long division. 52 divided by 4. It only goes one time into 5 with a remainder of 1. Drop the 2, and 4 times 3 is 12, remainder 0. So this goes exactly 13 times. And this is the final answer. So This expression, very, very, very confusing for people who don't know order of operations. You're not quite sure. Do you do the adding first? Do you do 7 plus 3 first? Do you do the exponent? Do you do the 4 somehow first? And we're doing the same thing every single time we do these problems. We're doing parentheses first, then exponents, then multiply, divide, then add, subtract. All right, next problem. Let's take a look at 2 times 3 to the power of 3 plus 8. Same thing. If you don't follow order of operations, what do you do first? The multiplying, does that come first? Well, no. First thing you do, check for exponents. I'm sorry, for parentheses. We don't have any there, so we do exponents next. We have an exponent right here. Now, 3 to the power of 3, what is that? We learned how to do exponents before. It's 3 times 3 times 3. All right? Now, 3 times 3 is 9, so this becomes 9, and then this 9 times 3 is 27. So the 3 to the power of 3 is 27. But I still have to rewrite the rest of the problem around it. I just did that first because that's the first thing order of operations says to do. I've done the exponents. Now, any multiplying and dividing, and then any adding and subtracting. What do I have? I have multiplying and addition. The multiplying always happens first. 2 times 27. Now, I'm not totally sure what 2 times 27 is. So I'll just crank through it myself. 27 times 2. 7 times 2, 14. 2 times 2 is 4. 1 more is 5. So I get a 54 right there. 2 times 27, 54. And then I'm going to add 8. And there's only one thing to do left, so of course I have to add it. 6 more from here would make 60. You can just count up. 55, 56, 57, 58, 59, 60, 61, 62. And the answer is 62. All right, so again, same order as always. No parentheses. Okay, we did that. Exponents, we did that. Then we had to do the multiplying. Then we had to do the addition. All right, making good progress. Let's take a look at the problem. 6 times 7 minus 5 squared. Now here's where we start to try to remember. Okay, at some point you have to take the training wheels off and just try to remember a little bit. What's the first thing we do? Always parentheses. Is there any parentheses? No, there is none. So we're done with that, right? What's the next thing we always do? Remember that list. The next thing is what? Exponents. Exponent. We have one of those, so we have to do it next. So 5 squared is what? 5 times 5. And that's 25. So basically we just replace this thing with 25. Everything else about the problem must be rewritten. Now think about it. After the exponents, what comes next? Always do multiply, divide, then do add, subtract. So I have multiply and I have subtract. Of course I have to multiply. 6 times 7, 42. And the last thing is to do the subtraction. So go over here, 42, 25. And we have to crank through this, unfortunately. So we have to make this a 12, make this a 3. What's 12 minus 5? That's going to be 7. And then they'll have a 1 right here. And so we get an answer of 17. And 17 is the final answer to that problem. Now, we're halfway through it, and what I advise you to do is when you're solving the rest of these problems with me, try to remember the order of operations instead of think about Pemdas and just try to remember, right? And if you can't, then of course go back and look at the list, and then over time you'll just remember. First thing, parentheses, always. Next, exponents, always. Next, multiply, divide, always. Next, add, subtract, always. That's it. It's 4 rules. We're going to remember it by solving lots of problems. Next problem. Let's say we have 8 plus 9 squared minus 5 plus 6. Very first step, what do we do? Always parentheses. 5 plus 6, this becomes 11, and the rest of the problem just needs to be rewritten. Okay, so once you calculate what's in the parentheses drop and disappear. This became 11. Next, after parentheses, exponents. Here we have a 9 squared. So let's go over here. 9 squared is 9 times 9. What is 9 times 9? 81. So what we're saying is that this 9 squared becomes 81. Everything else about the problem just gets rewritten. Now, after exponents, what? Multiply, divide. Do I have any? Nope, I don't have any multiply, divide. Next, add or subtract. And you always do it left to right, like reading a book. So here we have the left here, 81 plus 8 is going to be what? 89. And then I have to subtract that 11. So 89, if it were minus 10, would be 79. but it's minus 11, so it's 78. I guess I'll put it over here, 78. See if I can erase that, 78. And that's the final answer. All right. Trying to save my board space, so I'll make sure I have enough room for everything. Take a look at the next problem. Here's 11 squared minus 21 divided by 5. What is the first thing we always do? Always parentheses. So we know we have to do what's in here. But even within what's here, inside of what we have in here, we have a choice between exponent and subtraction. What always comes first? Exponents. Always. Subtraction's like last. Well, adding and subtracting come last. So we have to do this exponent. So we have 11 squared. 11 times 11. Now, from your multiplication tables, that's 121. If you're not sure, multiply it out, and you'll get 121. So we're going to have 121 minus 21 divided by 5. Now, this happens to be really easy. 121, take away 21, you're just going to have 100. Now that I've calculated it, the parentheses can now disappear. Now, the only thing I have left is to divide by 5. What's 100 divided by 5? You might not be totally sure. You could do the long division, but I'll go a different way and say, what is 100 divided by 4? It's 25, because it's just 25 cents in a dollar, which is 100 cents. So what's 100 divided by 5? It's actually 20, and if you're not sure, just multiply. 5 times 0 is 0, and 2 times 5 is 10. So the answer to 100 divided by 5 is what? It is 20, because 20 times 5 is 100. And hopefully you remember that. If not, you could also do the long division. Put 100 and divide by 5 and just go through it, and you'll find out that the answer is 20 there. All right, I'm on my last board here. I may have to erase something to get all my problems in. Really important to do a lot of these problems because you really should be practicing them with me. After you see me work them, just, play it again and solve them yourself. What about 4 to the power of 3 minus 2 to the power of 2 plus 5? Now let's try to remember it without looking at anything. First thing, do I have any parentheses? No. Okay, great, done. Next, do I have any exponents? Yes, I have this one and this one. Which one do you do first? Well, it actually doesn't matter. You can do them both at the same time, or you can do them one after the other. All you're going to do is calculate what this is and put it here, and calculate what this is and put it there. And you can do them, like I said, at the same time, or one after the other. So 2 to the power of 2 is 2 times 2, which is 4. What's this one? 4 to the power of 3. That's 4 times 4 times 4. So 4 times 4 is 16 times 4. And 16 times 4 you might not be totally sure about, so just go down here and say 16 times 4. 6 times 4 is 24. And that's 4, 5, 6. So what you get here is, kind of messed it up here, 64 is what you get though. I'm not going to scratch it out up there. So this becomes what? 64. This becomes what? We just said 2 squared is 4. And the rest of the problem just gets rewritten. So we do the parentheses first, but we don't have any parentheses. Next, we do the exponents. This exponent calculates to this one. This exponent calculates to this one. Everything else about the problem just gets rewritten. Now, we ask ourselves, do we have any, after exponents, any multiplying or dividing? We don't have any multiplying or dividing. Okay. Do we have any addition or subtraction? Yes, we have addition and subtraction. Now, if you follow Pemdas, then you'll say, oh, I'm going to do the addition first over there, right? But really what you're supposed to do is say addition and subtraction are at the same level as I've written here. They're at the same level here, and you do them left to right like reading a book. So really the best way to do it, the right way to do it, 64 minus 4 is just 60. And then now finally you're going to add the 5 for a final answer of 65. So 65 is the final and the correct answer. All right, let's take a look. 12 times 6 minus 3 squared. First things first, do we have any parentheses? No, we don't. Next, do we have any exponents? Yes, we do. We have 3 to the power of 2, which is 3 times 3, which is 9. So this just gets replaced with a 9. The rest of the problem gets rewritten for another step. So we've done the exponents. Next comes multiply, divide. But we have multiply here, of course, so we have to do that. What's 12 times 6? 12 times 6 from multiplication table, 72. Now we have to subtract that 9 away. So actually, I'm noticing a little bit of a typo in my problem statement. It's not a big deal, but really, instead of 3 squared in my problem, it's actually supposed to be 3 cubed. Let's see how that changes. We still have to do the exponent first, but instead of a squared, it's a cubed, which means it needs to be 3 times 3 times 3, which means it needs to be 9 times 3, which really means this is 27. So instead of this becoming a 9, this should actually be 27, and then that means this should be 27. So really, it doesn't change much. This becomes a 27. The 12 times 6 is still a 72. The final step here, I have to subtract here. So I have to take 72 minus 27. So I have to make this a 12. This becomes a 6. 12 minus 7 is 5. And then 6 minus 2 is 4. Answer is 45. So 45 is the final answer. All right. And here is our last problem. Let's take a look at 6 times 7 plus 8 plus 7 squared. So very first thing, do we have any parentheses? Yes, we do. We have to do that first. So 7 plus 8 is what? 15. Once I calculate, the parentheses go away, and the rest of the problem just gets rewritten. After parentheses, what do I do next? Exponents. 7 squared is what? 7 times 7, which is what? 49. So this 7 squared becomes a 49. Everything else about the problem gets rewritten. After parentheses and exponents, what happens? I have multiply, divide at the same level. So here I have multiply. I have to do this. So I have 15 times 6. 6 times 5 is 30. 6 plus 3 is 9. So I have 90 plus 49. Keep forgetting to put my equal signs. 90 plus 49. And then let me go over here and actually finish the problem up by taking 90 and 49, and we're going to add this. This is going to be a 9, and this will be a 13, so the answer is 139. 139, that's the final answer. So, you can see how I kind of structured this lesson. At the beginning, I reminded you, or taught you, what the order of operations are. For the first 2 or 3 or 4 problems, we went back to this list, and we used the list. But after that, I stopped going back to the list. That is on purpose, because I want you to remember this list without thinking about PEMDAS or thinking about, what do I do? Like, you just need to get comfortable with parentheses come first, then exponents, then multiply, divide at the same level, left to right, like reading a book, and then adding and subtracting come last, again, at the same priority level, left to right, like reading a book. After we do a couple problems, then I drop it so that we can just remember it as we do the problems. If you're still having a hard time remembering it, write this list down and use it. Absolutely use it. But after a while, you will not need to use a list because it'll be like, reading. It'll be like reading words in a book. You know how to read. You don't have to struggle to read anymore. So you're not going to struggle with this, but you have to practice. So practice every one of these problems. Write them down again and solve them and make sure you're getting my answers. Follow me on to part 2. We're going to practice more order of operations, crank up the complexity a little bit more even, and get more practice in the next lesson.